Okay, so hi everybody. And first I would like to thank the organizers for giving me the opportunity to tell about our experiences in this field. So, first I give a little bit of background, why there is such a big need for single cell and spatial training, why is it challenging? And then I move on to the experiences, the different approaches that we have tried. And to finish with, I will talk about some international collaboration efforts in this field. So I think we can truly talk about revolution here. So since 2013, when DNA and RNA sequencing of single cells was selected as the method of the year, this technology has been applied in many ways, and nowadays there are zillions of different seqs measuring different modalities in thousands or tens of thousands cells simultaneously. Then 2019, the single cell multiomics was the method of the year, and indeed we can also do multiomics measurements, so meaning that from the same cell we can actually profile it for different things at the same time. So all this, of course, allows characterization of rare cell types and diverse cell states. So it is well suited for studying things like development and disease pathogenesis. So it is very popular among life scientists. But it doesn't finish there. So then 2020, the method of the year was spatially resolved transcriptomics, and there are other spatially resolved omics technologies around. So there, the important thing is that now we also include location information, which is of course important because the spatial patterning of things and the histological organization is important. Now here, as in the other single cell stuff, we have a large number of different technologies and they are developing all the time. So there was a paper 2022 called Museum of Spatial Transcriptomics, and I really like this title because it sort of gives the idea that yes, we have lots of technologies, they tend to go obsolete, new ones come all the time. So all these technologies produce different kinds of data, new types of data. So typically the old analysis methods won't work anymore. We need new ones. And consequently, there is a large number of analysis tools being developed all the time. So in my example here, what I have is analysis tools for single cell RNA-seq data. And already for this modality, you can see that it's like 1,600 tools. So obviously as trainers, we need to make choices. What do we teach? All this creates a training challenge, and there are many aspects to it. So first of all, those measurement technologies keep changing, so we need to sort of bet on the right horse, if you like. So we need to keep in close contact with the core facilities producing the data to understand what is coming next so that we are ready to cater then the right type of training for that type of data. Then as there are so many analysis tools, we need to decide which ones to teach. People also want to know about data management. So what about the data standards? Then I would argue that the analysis methods for these types of data tend to be more complex than, for example, the ones for bulk RNA-seq data. So, and on the other hand, the audience, the people who we teach, the life scientists tend to have biology or medical background, meaning not very much math or statistics or coding for that matter. So all this makes it rather challenging. And then, of course, just the numbers of people who need to be trained. So, and down there, I have just listed some typical things you would cover in your course. So what have we tried then, our experiences? So first a disclaimer, so I'm only of course talking about my perspective. So I work at CSC, which is the National Supercomputing Center in Finland. And it's also like the National Bioinformatics Core Facility. So we provide training and user support and resources meaning computing resources and storage and this sort of stuff. Yes, so we are owned by the Ministry of Education, meaning that we need to serve all the universities and research institutes in the country. So what this means from the training point of view is that we have lots of people we need to train, and they are scattered around the country. Now CSC, we are like 600 people roughly, but we support all different fields of sciences. So bioinformatics is just one small slice. So we are not that many people. So we cannot, for example, analyze data for people. We often get that request that, oh, would you do this analysis for me? And we possibly can't, because everybody needs to be treated equally, and we cannot do that for every person. So because of this, training is very important, because we need to enable people to do the data analysis themselves. So it is critical that we get it right, because otherwise it causes us problems. Yeah, and so the people, like I said already earlier, they tend to have biology and medical background. And but the good thing is that the people who come to our training courses are typically PhD students, postdocs, or PIs. So they already have data, or they are just about to get the data, and they are desperate. And that's excellent for us, because they are prepared to do anything to learn. So we make use of that. So what have we tried? So we obviously started with the typical face-to-face courses, experimented with e-learning, flipped classroom, and we have been also using graphical user interface in the exercises. So when we started to give this kind of training back in, I think, 2016, so before COVID and all that, we were just running typical short training courses in our classroom, which can fit 24 people. And we had long waiting lists, and we were trying to select people like who needs this training most right now, and try to treat the different universities equally. That was difficult. But people came, and they were happy, but we noticed that this, so back then it was drop-seq data, so we were teaching the macroscope pipeline and some Seurat tools then for the actual analysis. And we find that when we try to cram all this information into people's heads in a couple of days, when they left the course, they were like, they looked quite disoriented and tired. And also from some of their questions, I could tell that they maybe didn't grasp everything. So then we started to think that, well, anyway, we have to, we need to scale up. And on the other hand, we somehow need to make this, we need to be able to give the theory in small doses. But then, because people are around the country, we cannot ask them to come like every week for a short lesson or something. So then we set up this Moodle-based e-learning course for single-cell RNA-seq. Yeah, it says with Chipster, so that's a web-based platform. I will talk about that a bit later. But yeah, so that contains this kind of topics you can see on the slide. And so what we have there is we have the lectures as videos. So we have both like the basic lectures and then some optional, more advanced lectures, where we have also collaborated with SciLife Lab, for example, in Sweden, and some other people. Then we have exercises, and we have quizzes, forum questions, and then people need to do final report, which we then check. And in general, the experience was positive. So most of the people actually did complete this. They got their certificate. We got good feedback, but there is a fair bit of maintenance burden, because these tools keep changing often. So then you need to go and update that here. And I also felt that the quizzes we had there were maybe not that good, because so they are automatically checked by Moodle. So the questions you can put there need to be relatively simple. You cannot have these open-ended questions. So it was difficult to check if they actually really understood some of the concepts. So then came COVID, and everything went online, and then we realized that maybe we don't need to get everybody to Zoom to listen to the lecture passively, because they could actually do it at their own pace and in small chunks. So then we started to record more lectures, and we had already been doing that for the e-learning, of course. But so this, maybe you are familiar with the flipped classroom idea, but basically it comes from, I think originally maybe from the universities, where people would come to the lectures and then they would do their assignments at their own time. So flipped means the other way around. And in our case, what it means here is that so the participants get the lecture videos a couple of weeks before. They can watch them at their own pace. Then they also get a set of questions which helps them to sort of check if they got the main points. And then when the actual course day comes and we get together, then we do recap the main points. But then the emphasis is really on doing exercises and discussing. So, and we do it topic by topic. So for example, clustering, we recap, they do exercises, we look at the results, we discuss, and then move on to the next topic. And the actual course day can be either online or face-to-face. So when it's when we use R directly, then we have been still doing it face-to-face. But when we are using the web interface, we are doing it online. And the advantage of doing it online is that then we can actually spread the course. Like we can have shorter days and spread it for a longer time. People have quite liked that. So this seems to work. So people seem to be able to digest the heavy theory better. And when they come to the classroom, they are well equipped, and boy, they ask a lot of questions, and they are good questions. So you can tell that they got the point, and now they just want extra stuff. And of course, then for us, we can keep the actual course duration shorter because they watch the lectures at their own time. So we have these lecture playlists that they get. And I mentioned that they get set of questions. So here I have the typical questions for single-cell RNA-seq course. So people are meant to know this stuff before they come to the classroom. So you can imagine that the questions that they come up then afterwards. And now we have actually started to collect. So as we run the course, they are also meant to write their questions in a Google Docs, so that, and we answer, but we also write our answers so that people can come back to those later if needed. Okay, then I will move on to the idea of using a graphical user interface to analysis tools. So often if your audience is life scientists, they probably have limited R and Python skills. So then when you are teaching, they actually are dealing with two things at the same time. So they are they have to cope with R or Python, and at the same time try to understand the actual topic you are teaching. So if you wanted to make it lighter, you can use a GUI for the exercises. So for example, we are using Seurat package mainly. So we either run it straight in R or we do it through the GUI for this life science audience. And we find that using it allows people to focus more on the actual analysis concepts and pitfalls than just running like ready-made code. What we always also see often is that we have these happy faces and people going, yoo-hoo, I can actually do this. I never thought I could do this, because they have been a bit scared about bioinformatics. So having this, that they feel empowered, does encourage some of them then to take the time and learn R or Python. And for us as trainers, of course, using this kind of like web-based system ensures that everybody has the same environment, so there are no hassles in terms of installation or or memory running out or something. So there are different kinds of web interfaces. In our case, we use Chipster that we have developed at CSC long time ago for other things, and hence it's called Chipster because it was originally developed for microarrays. So we have the same problem as the Array Express people. So lesson to learn from this: if you develop software, never name it according to measurement technology because that changes. Anyway, so Chipster is open source. There are lots of analysis tools for different types of data, but now I will be focusing on the single cell and Visium data. So Visium being the spatially resolved transcriptomics data. Now, from trainer's point of view, what is good is that in Chipster, users can share analysis sessions and the analysis metadata is tracked. So we use this in 2 different ways during the course. So firstly, if somebody gets into trouble, they can easily share their session with us. We can see exactly what they have done. And also after every course day, we ask people to share their sessions so that then we can sort of quickly check if everybody is doing more or less the right thing. Yeah, and otherwise, well, we have plenty of training resources available because the universities use this for undergraduate training. We don't really do undergraduate stuff, but universities do, but they have then access to this. And we also provide training accounts also for people from abroad. I also added a couple of technical sentences there, but I'm not the person who can give you details on that one. Anyhow, so that's what it looks like. Like this particular stuff here is doing Visium data analysis of 2 samples. So we have like tool categories and then tools, and people can fiddle with parameters and look at the actual code as well if they wanted. Otherwise, during the course, we look a lot at the different plots, try to understand what it means, what you need to think to set your parameters in the next tool. And here we have a YouTube channel where we put those course playlists, and there is a lot of other stuff as well. Anyhow, so now I will move on to international collaboration in this field. I will be talking about GOBLET and Elixir single cell omics community. So first about GOBLET. So GOBLET stands for Global Organization for Bioinformatics Learning, Education and Training. And its vision is to unite, inspire and equip bioinformatics trainers worldwide. So it has both institute and individual members. And for single cell and spatial activities, so GOBLET actually organized back to 2021 a workshop for single cell RNA-seq data analysis trainers. I put the URL there because there are all the slides and actually the talks were recorded as well. And now this year, together with the Elixir single cell omics community, GOBLET organized the workshop for single cell omics data analysis trainers. Then moving on to the Elixir single cell omics community. So I think I need to put that a bit in a context because maybe not everybody is that familiar with Elixir. So Elixir is this intergovernmental organization. I think there are now 24 nodes. The hub is in Kingston next to EBI. And Elixir consists of these rather technical platforms such as compute, data, tools, interoperability and training. But then more recently it has set up this, what is called communities. And here the idea is that the communities link this technical infrastructure to life science experts. And these domain experts can also come from like non-Elixir institutes. So like you can see, there are different kinds of communities. For example, metabolomics, plant sciences, proteomics, things like that. And so rather recently, we set up this single cell omics community, and there is a strong emphasis on training. We also promote systems for benchmarking analysis tools because, like I said, people need to make choices. And there is also work on standards and interoperability. So if you want to read more about it, there is this F1000 paper where you can read about the plans. There are quite many countries involved, and if you want to get involved or know more, you can email us colleagues, so you have the email address there. But now I will say a couple of things what we have done in terms of training so far. So we got our first funding in the beginning of the year, so it's still a bit early stages, but SIB hosted a first workshop now together with Goblet for data analysis trainers. Again, you have the URL there. So we had some presentations, but very good discussions as well. The presentations are available as videos and the slides are available as well. Then right now, there is this training survey open where we want to understand, well, what is the training landscape in this field? Is something missing where we would need to work together, perhaps? And also if we can collect links to training materials, that would be great. So everybody in this room who is working on this kind of stuff, please answer the survey and do it soon because the deadline is the end of the month. Otherwise, we organize or participate in biohackathons with different projects, like you can see here. So the upcoming Biohackathon Europe, there are 3 projects from us. And especially the last one, they're focusing on this kind of continuous benchmarking of analysis tools. I think is very relevant for us as trainers as well. And we have been running different workshops already for a while on different aspects of things. We are setting up a website. This is still work in progress, but I wanted to give you the URL because hopefully by the autumn you have more stuff there. And there is a YouTube channel as well. And then to finish with, I just want to say a couple of practical things. So collaboration, of course, can come in many forms. One obvious one is sharing training materials. And to do that, you want to make your materials fair. So I think already today we will have a couple of talks about how to do this. But I just wanted to point out that there is a very nice fair training handbook made by the Elixir training platform. There's also a good article about this. Then when you share your materials, well, you need to put it somewhere where people find it. So there is the Elixir training portal tests is one option. Again, there is a recent article on how to do that. And like I said earlier, we aim to collect some links also on our community website later. And then finally, I just want to encourage you that when you give your training, can you please record your lectures and make the videos available, because it would be super useful for many people. So other trainers can learn from you. They can also incorporate your lectures in their own courses if you give them the right to do so. We have been doing that with some people and it has been very beneficial for us. Obviously, learners can use those videos for self-study. And then finally, so if you go for this, don't aim at perfection, because if you keep polishing them, they are outdated by the time you are ready. So just quick and dirty is the way to go here. And what I have in the image here is from a course that I organized 2019. So those course videos have now had like 50,000 views. So I just want to make the point that people really do actually watch them and appreciate them. So to summarize, I was saying that this field is moving really fast. The number of analysis tools is like, well, growing rapidly, which creates a big training challenge for us. The flipped classroom seems to work. Actually, for us, it works better than the e-learning, because people said, oh yeah, this e-learning is nice, but you know, we still want to have also the course where we can interact with the trainer. And otherwise, graphical user interface allows the people with life science background to focus on theory better. And international collaboration is beneficial in this context because there is just so much to cover. And then I would like to acknowledge first people in my team, especially Maria, Ida, and Lauren, who have been working on the tools and giving training in this area. Then people in the University of Helsinki and also the core facility there. We have been doing training together with them as well. And then finally people in all the people in the single-cell omics community of Elixir. So now I would like to thank you for your attention, and I would like to invite you to the ECCB to Finland next year. So, thanks.
Thank you very much, Eija. So I think we've got time for some questions. So has anybody got any questions for Eija? Okay, let Michelle go first.
Thanks, Eija. So I'm always confused, and I'm going to ask the question again, just in case other people in the audience have similar questions. So you have a survey for the single cell community, but is it just Elixir, or are North American participants? Like, I'm never clear on the Elixir or Elixir Plus aspect of things.
Yeah, okay, it's very good that you asked the question. So yes, absolutely, that survey is open to everybody, and I have been looking at the answers we have got so far. So yeah, we have got answers from around the world, so please answer. Yeah, and many of these activities we do are also open for everybody. So there might be like some of the workshops I mentioned, well, the travel funding to the workshop is limited to the members of Elixir countries, but otherwise, you know, we want, it's more important that you are an expert in this field rather than if you happen to belong to the right institute. Yeah.
Thank you for a great talk. I'm very interested in how the short course kind of training formats intersect with degree program trainings. And in particular, you commented on the challenges of teaching biology and medical people in these tools. Are there things that you think need to change in how people are getting degrees in biology and medicine to better prepare them to be able to work with this kind of material in the future?
Yeah, I don't know. So actually our materials are used by the universities, for example, in med schools. So they seem to manage that. They use it directly as it is. But I'm sure that it could be perfected somehow. And also, well, just to, yeah, it really depends how much people have background information, for example, of these technologies, the actual measurement lab technologies. So we don't cover that because we assume that people have that already. So then we only talk about some of the implications to the data analysis. So maybe that at least I would add. And then of course, if you think about the degree courses in wider perspective, then you also want to think how you prepare people, because these things are changing all the time. What we teach now is going to be outdated in a couple of years, certainly. So what is like the foundational skills you want to give to those people? Yeah.
I'm actually going to go to an online question at the moment, seems we've got one here. So this is from Kath, who's joining us online. She says, thank you for a great talk. Do you have any stats on the longer term impact of the different types of training? It would be good to compare the original face-to-face approach with your current approach.
Yeah, we haven't been really in a structured way collecting long-term impact. It would have been very interesting. Of course, what we do see is because typically the people we train are also our users. So then if they have problems, they contact us for user support. So at least we see like who is using, also when they are publishing, we see that, okay, great, they managed. this kind of stuff. But no, we haven't done structured stuff. But if I had to guess, I would think that the flipped classroom ones would probably be doing best because they really seem to understand what they are doing.
I guess it's the interaction you're getting with them as well that you can see in the questions you say. You can see it's getting in more than it did with the face-to-face. So.
Yeah.
Brilliant, thank you. Right, who?
I wanted to ask what are the advantages of using the customized platforms that you have in comparison to existing platforms like Coursera or UDX? And my question basically is tied to the question of how people obtain the certifications. And if, for example, they need to prove to a future employer or person who hires them for PhD that they have the relevant training, how do you treat this sort of situation?
Yeah, okay. So we haven't, so like I said, our trainees are usually just desperate to get the skills and they need to get the job done quickly. So we haven't really thought about the aspect you mentioned so much. Well, they do get a certificate and the university would give like this, what are they called? Study credits, a certain number for attending this kind of course. So that we have, but we haven't really, yeah, because these courses are so short, we haven't really thought about more of that aspect, but we should, yeah.
Thank you.
Eija, you talked about using a we because some people are not so familiar with R and Python, and I understand how that helps, but I wanted to ask whether there are also some courses that you do only with R or Python aimed at people that already have that knowledge.
Yeah, we do in R. So far it has been in R, but I think it would be moving to Python at some point.
Thank you, Eija. Thank you for your talk. Wonderful. I wanted to ask you something about the flipped classroom as well. So one of the things that you were saying about the e-learning is that the maintenance is kind of heavy in a sense. The flipped classroom, you also use where the lectures already recorded. There's also some kind of maintenance on that as well, no?
Yeah, but like I said, if you don't aim at perfection, that is not so bad. But whereas the updating the model, well, I guess you get used to it as well, but still. And it also depends on what kind of questions you ask in Moodle. So now I have learned that you want to avoid certain types of questions because they're old in no time, but yeah.
Because my other question as well was more on the on the scaling, you know, because scaling. And do you also feel the same problem with the scaling up? You can have even more people attending the flipped classrooms?
Yeah, so when it was in the classroom, the old days, we could take 24. Sometimes I squashed in 30 people, and then would get complaints from administration that it's a risk, a fire hazard and whatever. But now for the flipped classroom, which we run online, there we have been taking 40 to 50 people, and we have several trainers as well. So that way we can scale up.
Any further questions? We have time for that.
I was thinking, what is the time commitment for a flip class? Like, how much time do the researchers have to dedicate?
Do you mean the preparation or the actual?
No, for the researchers, for the attendees, for the.
Right. Okay. So, well, they need to watch the videos all together. Well, it also depends if they sometimes they tell me, oh, I was watching that 3 times and then I understood what you were saying. So it depends.
Days, it's days?
Days, yes.
And it's all in the row or like spread through?
So
it's at their pace.
Yeah. So, well, so what the first part, which they do on their own, they of course have the freedom to choose when they do it, when they answer the questions and all that. Then when we are in the classroom, so far we have been running it on consecutive days. And we were thinking, since we are doing this online, we could actually spread it over several weeks and give them homework in between. But they didn't want that. So now we are stuck to this. Yeah.
Okay. Any fun? Oh, we got one at the back.
Hi, wonderful talk. So I wanted to ask you also about the flipped classroom, because I do have that kind of give that kind of training in a flipped classroom. This is for master and in bioinformatics, and one of the issues that I encounter is that I tell the students for next class we're gonna discuss this topic. You should see this lecture. When the time comes, half of the class probably were busy with something else and they don't come prepared. In your experience, everybody comes well prepared apparently.
Yes, but you know, like
How
I
do you
said,
make it?
they are desperate. So you want to teach people who are desperate to learn.
Because on the other hand, we are saying at your own pace, right? But then it's not really. You have to be ready by the time we discuss here in class. So okay.
Yeah, but yeah, I guess, well,
I don't know if anyone has any advice. I'm glad to take it.